Access denied. Access granted.
Let's get started. The internet actually got its start over 50 years ago, and computers back then filled up entire rooms. Scientists and researchers used it for years to communicate during the Cold War. It was useful because if one computer went down, the others wouldn't follow. In 1962, a scientist named J.C.R. Licklider proposed the idea of a network of computers that could talk to one another. In 1969, the first ever message was sent from one computer to another over the ARPANET, the government's computer network at the time. ARPANET stands for Advanced Research Projects Agency. One was located in a research lab in UCLA and the other at Stanford. All the message said was log in, and it didn't fail to crash the network. Stanford only received the first 2 letters of the message, but hey, you gotta start somewhere. By the end of the year, only 4 computers were connected to this network. In 1971, the University of Hawaii's Aloha Net was added, followed by various networks in London and Norway 2 years later. Also happening in 1971, Ray Tomlinson was developing the first system to send mail back and forth between the users of ARPANET. This would eventually be called electronic mail or email for short. The @ symbol was used to tell a person's name and the host name apart. With all of the networks floating around, there needed to be a way for all of the computers on them to communicate with other networks. This is where computer scientist named VINTON CERF comes in. He invented a way to introduce computers across the globe to each other in a virtual space. This invention was called Transmission Control Protocol, or TCP, which was followed by Internet Protocol, or IP. In the 80s, scientists used CERF'S protocol to send data back and forth, but the 90s is where it really all began. In 1991, a computer programmer named Tim Berners-Lee invented the World Wide Web. This wasn't just a data sharing space for scientists anymore, this was an entire network of information that was accessible to anyone with an internet connection. You're using a browser right now to watch this video, and some of the popular ones are Firefox, Google Chrome, and Safari, but in 1992, Urwise was created. Urwise was an internet browser and the first to have a graphical interface. A few browsers came before and after, but in 1993, MOSAIC was created, and it would popularize surfing the web. MOSAIC influenced many of the browsers to follow, including Netscape Navigator in 1994. This became the most popular web browser at the time, accounting for 90% of the web usage in 1995. In the early 90s, companies like AOL and CompuServe were starting to provide dial-up internet access. Dial-up is a method of connecting to the internet via a telephone line. Your telephone line was plugged into a modem and the other end was plugged into the phone jack. There was a period in history where you couldn't use your telephone and the internet at the same time. Without the internet, we obviously wouldn't have things like Facebook, Twitter, and YouTube, but way more importantly, we wouldn't be able to access information in seconds. We wouldn't be able to communicate with people from around the world, share ideas, and educate those who might not get a chance elsewhere.
The internet works through a massive global network of optical fiber cables. In this animation, you can see how data typically flows between the different levels of internet service providers in the modern internet. The optical fiber cables carry signals in the form of light. However, your laptop or a mobile phone processes electrical signals. So, how does this conversion of light to electrical signals happen? And more importantly, why is the internet structured the way it is today? Let's talk about the structure of the modern internet. This animation shows different internet service providers. For instance, AT&T is a Tier 1 ISP. You can see how optical fiber data starts from the landing stations and reaches your home, passing through many levels of ISPs. But first, let's get into some history to understand more about the evolution of the internet. The internet was made available to the public for the first time in the 1990s. The very first internet used the same line cables as your telephone, specifically coaxial copper cables, and it worked completely on electrical signals. A splitter divided the internet signals from the telephone signals. It is impossible to mix different electrical signals together and then separate them out. Either telephone or the internet signal was sent at a time. So, with this technology, whenever you used the telephone, your internet connection was lost. Another disadvantage of this technology was its very low data speed and the issue of interference. Any cable which carries electrical signals generates an electromagnetic field around it. The signal becomes prone to interference from any other electrical power lines or communication lines. In short, it is not a good idea to transfer internet signals in the form of electrical pulses. This is why optical fiber cables replaced coaxial cables after a few years. The light signals have no interference issues. Moreover, you can mix different signals together in an optical fiber cable using WDM technology and separate them out after the transmission, which is why optical fiber cables provide very high data speed. In a data center, every server has a device called an SFP transceiver that sends and receives optical light signals. This device uses a laser to send light signals through an optical fiber cable. The bulk of the data transfer occurs through the optical fiber cable in the form of light. Before feeding it to your laptop, another device on the user side, called an optical network terminal, converts the light into electrical pulses. The ONT is basically an advanced version of a modem. Let's see how light signals are converted into electrical signals in an ONT. First, a photodetector receives the incoming light signal. When the light falls on the junction of the diode, it generates electrons and holes. The holes are attracted toward the negative side of the battery, and the electrons are attracted toward the positive side. This is how an electric current is produced in the circuit according to the incoming light signals. The ONT is connected to a router with an Ethernet cable. A router is a networking device that receives, analyzes, and forwards data packets to a device that has the same IP address as the data packet's destination address. The router will be able to understand these electric signals. The connection from the router to the device can be either wired or wireless. Advanced Ethernet cables can transfer data at speeds between 10 to 40 gigabytes per second. But as we know, transferring data through copper wire has an interference issue. Length of the Ethernet cables are limited due to this issue. You can see that the Ethernet cables are well shielded. Moreover, they are twisted pair cables, which can reduce the interference issue to an extent. Advancements in technology have further reduced the use of copper cables. The technology is known as Fiber to the Home, or FTTH. In FTTH, fiber cables reach your home instead of copper cables. This animation clearly shows how the light-to-electrical signal conversion happens in FTTH. FTTH service provides 1,000 megabytes per second of data transfer speed. We hope that this video has helped you understand the structure of the modern Internet. Thank you for watching.